This is the first condition. This is for r equal to 0. Now let me take the next condition. Second case, let small r equal to r by 2. Where the force is applied at a distance r by 2 above the center of mass. We have to check in what direction the friction will act here. I don't know this. What about the friction? Okay, let's substitute. What is IC equal to mr square? Substitute here. Small r equal to r by 2. How the friction still will be acting backward only. Who will decide? You look at this particular thing. So how much friction force, that also we can predict here. The friction I'll put, it will still act backward only. Then how much of that friction force can we calculate this F according to the formula? Capital F m r by 2 r for moment of inertia of ring mr square plus mr square. Tell me now how much it is. F by 4. And we got negative, no? What do you mean by negative? Negative means what I should conclude. It will act opposite to the applied force. Better say not right, left. It will act opposite applied force. Positive means it will act in the direction of applied force here. Now let me apply the highest point. Third case, let me apply the highest point here. This is very important. In the books, what happened, they have not explained very clearly. That's why you find very difficult. Very, very random way things in the books they have put it. Okay, this is radius r, center of mass. There's a point. What about the surface rough? According to the formula, everything is there in front of you. Just clearly put it here. No. What is smaller? Third case. Smaller equal to capital R. Where it is acting now? It is acting exactly at highest point here now. I'll wound a string, then I'll start pulling it. Though I kept on rough surface. What is the frictional force should be? Small r equal to capital R. The frictional force in fact will be 0. Why 0? Because small r equal to capital R. Substitute that in this equation. Or I'll show once. Fine. So no friction force will act. Then sir, who will rotate it? The applied force only. Acceleration of center of mass. This one. So what are the equations of motion? F into R equal to IC alpha C. Then AC is equal to, or F is equal to, the same force will produce translative motion. Means though surface rough, no friction. Means now, let me do one thing. There's a ring. And let me call this is a smooth. Then can it have pure rolling? Yes, it will have pure rolling. Will this? It's a ring. The force is applied at small r equal to capital R. Again, the same condition. Though surface is smooth, what happens? Still, it will have pure rolling. So, is it a friction necessary for pure rolling? The answer is no. Looking at this condition. Looking at this condition. Looking at this particular condition, the last fourth case. Though surface is smooth, the body is having a pure rolling. Now also what happened? We are discussing for pure rolling here. Able to make it out? This one? Okay, let me shift that particular So now, so though surface is rough, what point friction will be zero. So shall I call that as a threshold point? Means at what point I should apply a force on the ring so that though it is kept on rough surface, frictional force will be zero. At highest point you should apply for the ring. That's what it's telling. Okay, let's analyze this particular situation for a disc. Then we'll see what conditions will come. Same thing, we will check this condition for a disc now. I'll keep this equation. This is very important because I think just it's a idea, that's all, nothing is there. There's no any big, already we have covered most of the ideas very systematically, that one. We should know how to apply this formula now. So I'm starting this for a disk of mass m. No, let's come one by one. Where is the force? First, let me apply the force here. This is R, this is a point P. So this is a disk, and we know moment of inertia how much? M R square by 2. Where applied force? At the center of mass. And this is a rough surface. Okay, according to this formula, substitute here. Can you predict the direction of friction? Sir, already we did. It will be backward. Now, from this formula, I'm trying to cross check here. So if I substitute this, this will be F into M 0 capital R mr square by 2 by mr square by 2 plus mr square. So this will be how much? Minus 2f by 3. What do you mean by negative sign? Will act opposite to applied force, so that the friction will act here. Then center of mass will accelerate. Then this one. Okay, next condition. Now I'm going to apply a force exactly at a distance r by 2. Let's see what conditions I'll get it. No, put small r here. There's a point P. Small f is equal to f into m r by 2. Second case, so first case r equals 0. What about second case? Small r equal to r by 2. I am getting 0. So now if I apply force at a distance r by 2 above center of mass, the center of mass will have, say like the body, rigid body will have pure rolling and no friction will act, though this is rough. So shall I say where is the threshold point for a disc will come? At r by 2. If you apply the force F at a distance r by 2 above center of mass, no friction will act here. Sir, how do you can see? Already I brought a proof, no? Sir, let me apply at a distance less than r by 2. We'll see what conditions will arise here. Now I'm taking the third case. Where is the force? The force will be a third case, smaller equal to r by 4 I'll bring. What is r by 4? Shall I say r by 4 is less than r by 2? Anybody looking at that? You should tell me, like, what about the direction of friction? I think straight away we have to substitute the formula, no? Small r equal to r by 4. Check it. The friction will be negative, will be backward. And look at the magnitude also. It will be different. It cannot be all the time 2F by 3. It also depends upon where you apply force. So if I substitute all that formula, small f is equal to f into m r by 4 r mr square by 2. Anybody answer? How much f will be? Small f will be? Mr square will get cancelled. So 1 by 4 f by 6. Yeah. Now look at the frictional force. Frictional force also depends on what, like rolling friction, depends upon the point of application of what. That's what I mean to say here. F by 6, F by 3, why different answers? 1 by 4 minus 1 by 2, 1 by 2 plus 1, here 3 by 2 will come. Do calculations, please tell clearly.
Sir?
Okay, no, so F by 6 will come. So how the friction will be backward here. Let me take a point, the third case. Small r is equal to, fourth one, small r small r is equal to, let me make it, I should make it more than 0.5, no? So I'll write 2r by 3. 2r by 3 is definitely greater than 0.5. Now tell me like how the friction force will act here. Yes, anybody? Value? Negative or positive first? Friction force will be positive. Anybody value? F by 9. Huh? Now look at, no, the frictional force. I think this everything you have got very very clearly, that one. If you apply force at the center of mass, it's like backward. If you apply force at r by 2, I'll call this is threshold point. The friction will be 0. If you apply force below the threshold point, friction will be backward. If you apply force above the threshold point, what is the threshold point? R by 2. 2r by 3 is greater than 0.5. 0.5r. So now, if you apply force above the threshold point, friction will act in the direction of applied force. If you apply the force at a distance less below the threshold point, friction will act opposite to applied force here. There's a one very firm conclusion is what we are making, and this is applicable only when you apply one force. If you apply more than one force, again this is of no use. We have to derive equation and we have to conclude here. Able to make it out, this one? So shall I say threshold point? So what is the threshold point? F by 3. Now what is the threshold point? Threshold point is one where if you apply force, that will add the friction, rolling friction will be 0. Above threshold point, it will be friction will act in the direction of applied force. Below threshold point, friction will act opposite to applied force. Similarly, for a solid sphere, can you tell me where the threshold point should be? So IC, what is IC is equal to? Friction should be 0, no? For that, can you assume the value of small r? 2r by 5. So therefore, similarly for solid sphere, what all we discussed with that? Next, we'll take the solid sphere. If there's a solid sphere, where is the threshold